Thanks all for joining. This is Ken Oestreich with Genera. I run marketing here, and I'm joined by Peter Van Oven. Peter, you there?
Yes, good afternoon, or good morning, depending.
Peter's
As
joining
you can tell from the accent, I'm based in the UK.
Joining us from across the pond. So today we're going to take a little bit of time and talk about virtual environments and virtual I/O and how that contributes to providing high availability and disaster recovery. So I just like getting a little housekeeping items aside so that expectations are set. I believe you can type in any questions for either of us at any time in the window on the left of your screen. You can ask any time. I believe there'll be live questions or typed in questions at the end of the presentation as well. I think this is going to be well under 45 minutes. I think Peter and I are probably going to be only 30 minutes or so of talking, but I bet it'll provide fodder for some good questions. We'll talk a little bit about ourselves, some terminology today. I want to discuss a little bit about sort of what's virtual in IT, or at least what's about to be virtualized, and what's not yet virtualized in IT, and maybe there's some opportunity there. What we mean by converged infrastructure, which is a technology that's kind of at the central of today's webinar, and a little word about eGenera product, but not too onerous or commercial. And then we'll open it up for Q&A and a little special offer. So with no further ado, Peter, do you want to introduce yourself and then we'll get going?
Yeah, certainly. Thanks, Ken. My name's Peter Van Oven. As you can tell by as I said, the accent, I'm one of the pre-sales engineers based over in the EMEA region. My background is with virtualization, channel partners, and building virtualization practices. And previous to that, I actually worked for Citrix as a lead engineer, responsible for things like Zen Desktop and Zen Server through the HP and Dell relationships. And funnily enough, before that, I spent an awful long time with Compaq and HP. So it's always good to put the Compaq name back in there and see it back in life.
Great.
Thanks, Ken.
Good. And again, I'm this is Ken Oestreich. I run marketing here, but before I donned the marketing hat, I was actually with Sun Microsystems developing markets for things like Corba middleware and Java, and got into data center automation and whatnot. So hopefully you won't hold my marketing title against me. So let's just get going here with no further ado. So the terminology we're going to hit on today, we'll talk about converged infrastructure and what that means. But real briefly, we're talking about essentially virtualizing infrastructure as opposed to virtualizing software. We'll talk about converged networking, the technology whereby essentially a single physical wire might carry the traffic, the packets of many logical wires, both storage and data, and network traffic. We'll talk about HA&DR, high availability and disaster recovery. Obviously, central to the conversation, we're going to be talking about I/O virtualization, right? The logical creation of I/O ports as opposed to the physical I/O ports that are on compute resources. And I want to distinguish I/O virtualization from OS virtualization, right? The VMware and Citrix and Microsoft technologies that everyone's familiar with. And I draw the distinction only because people just sometimes say virtualization, and we want to draw a distinction between what the thing is that's being virtualized. So, Peter, hold me to account to make sure I put an adjective before the word virtualization all the time.
Yep, you have to watch out today, Ken, because there's a techie on the line.
Precision.
So marketing guys, watch out.
Precision is next to godliness. So real quick, I want to throw a little trick question in here for the viewing audience, which is, how new is I/O virtualization? How long has it been around? It seems that some would think that it is relatively new. So hold that thought as we cover this technology. So let me just launch into the presentation then. So what's virtual and what's not, right? Everyone, I think, is pretty familiar with this diagram, benevolently ripped off from a VMware presentation. And if you look at this, it's obvious that the virtualization everybody thinks of today is OS virtualization, software virtualization, where applications and operating systems are encapsulated and separated logically or shimmed away from the x86 architecture, right, with a hypervisor software layer. And what sort of played down in this picture are the things that are not virtualized, right? So you've got the hardware. You've got the CPU and the memory and then the NIC cards, the network interface cards, and actually there's HBAs, host bus adapter cards, and the disks. So the thing is, no one really has addressed adequately in the market the need or benefits of virtualizing some of this stuff in addition. So virtualizing the physical NICs and disk connections, host bus adapters that are physically on your host systems. Those are still static, physical, we call them stateful pieces of hardware, right? They have worldwide names assigned to them and MAC addresses assigned to them and IP addresses and whatnot assigned to these things. So sort of the challenge in the conversation today is, well, what if you could sort of vMotion, that's a VMware term, those things too? What if they were virtual and you could move these seemingly physical devices on your hosts around in your data center, right? So what if you could move the NICs, the network interface cards, and the HBAs, well, their addresses, their worldwide names, their ports. What even if the consoles for the physical servers were virtual and you could move the console around from one machine to another as the workloads moved, and what sorts of benefits would that serve you in a virtual environment? And that's kind of at the core of what we're going to be talking about today. So let me shift gears and kind of contextualize all of this for everyone. This is sort of a very schematic view, hopefully it's rendering properly, of how virtualization-based high availability works today. And really what you see is a stack of software. There's two CPUs. Each CPU is running a hypervisor or has become a host. There's an application running on CPU A. And both of the CPUs, both of the hosts, are provisioned with their I/O cards and their storage I/O and their networking and their switching, etc. So everyone is probably familiar with this, that if there's a failure, the application can be moved or reconstituted onto another host nearby or far away. And actually this is how vMotion works as well. The thing I'll point out, and people take this for granted quite a bit, is obviously you need two hosts, two host licenses. You need all of the I/O and networking on that recovery host, that's CPU B, pre-provisioned. It means you've paid for those cards, you've wired that networking, and it's sort of sitting there waiting to be used. And heaven forbid the infrastructure on your recovery blade or recovery server doesn't match the infrastructure on your primary production blade, you might have a little difficulty, or you might have to go out to the server floor and with a screwdriver and change a few things. So that's somewhat of the pain point I want to address in later slides. So now let's kind of return to the picture of the data center, maybe a more detailed view of that stack, and help define what converged infrastructure does relative to OS virtualization that we just showed the picture, right? And here's a stylized stack of things you have in your rack, right? You have at the top, the OS and the applications running on a server somewhere, whether they're blades or a rack server. Plugged into the bottom of that server are your I/O devices and your cables and your switching and your ports, and then of course those switches are connected to your backbone network and or your shared storage. And everyone gets this, right? And when we look at virtualization's play in this stack, we all recognize, it abstracts the software, right? That's a given. So my challenge is, well, what if you could abstract all the stuff down below, right? And that's what we mean by converged infrastructure. Your infrastructure is now sort of one virtually composable set of resources. And sometimes we say that it's poolable. Sometimes we refer to it as logically definable. But what it means is now you're not using all of these physical items you need to buy and install and maintain and manage, etc. There's some nice properties of this and some analogous properties to virtualization. We all kind of know that the hypervisor abstracts the software. It gives that software portability. You can move it around. Agility and all those good agility words. It simplifies the provisioning of those virtual servers and consolidates them, right? So you make more efficient use of hardware capital. Well, I/O virtualization and converged infrastructure does the same thing analogously for your infrastructure. This time you're abstracting all of that I/O and that networking and that switching. It means that that is now portable. So the configuration you have of virtual NICs, virtual HBAs, networking, VLANing, switching, etc., is all portable. Right, so all the I/O and the networking is agile and portable. Obviously, this greatly simplifies infrastructure provisioning. You change from somebody walking out on the raised floor with a screwdriver and a static-free box to someone with a mouse. And the nice thing is it also consolidates. Right, you're going from lots of physical hardware down to actually fewer pieces of physical hardware being utilized at a higher rate. And I'm talking about networking and I/O.
Okay, just one.
Yep.
Yeah, I was just going to say it might be a good point here to actually kind of describe exactly how the generous solution abstracts the infrastructure, and that the fact that we're not another hypervisor and that we don't add additional resource to a software stack, and that we use drivers to do this. So one of the confusions that when you see this is from where I've seen it, Ken, is people think, oh, you're just a hypervisor. So maybe we just want to kind of spend a couple of minutes describing how we do it.
Right, and there, to be honest, there are lots of ways to do this. I know some vendors that have hardware appliances, for example, that do this as well. Our approach happens to be software drivers. But really, I want to get the concepts across here first. So let's move on, if you don't mind, and kind of go back to like sort of a different way to approach high availability and disaster recovery, which is sort of what this whole webinar is about. So now let's go back to that stack, but this time we're going to look at high availability or disaster recovery in the context of converged infrastructure. And so we have sort of the same stack with CPU number 1 on the left, and it's provisioned logically now with I/O, storage I/O, and network I/O, and network switching. But this time, that's all converged. It's all virtual. And you're running on that CPU your hypervisor, your VM, and your app, or for that matter, actually, it turns out it could be a native OS as well, but we won't go there right now. And should a disaster strike and CPU 1 fails, what you can do now is move the entire state and I/O configuration and addressing and naming and storage connectivity, etc., from CPU 1 over to CPU 2. This takes a minute or two. And then now that your storage and your application are pointed to CPU number 2, you simply reboot, right? That application reboots, or that host hypervisor with its guests reboot on CPU number 2, essentially never knowing that they've moved, because CPU 2 presents itself to the OS, to the hypervisor, identically to what CPU number 1 was. And the nice thing about this is what we've done is we've changed the I/O and the infrastructure profile, and that's completely transparent to the OS that's residing on that CPU. So it actually doesn't even need to be a hypervisor that's there, to tell you the truth. But we've done so by virtualizing the I/O. We've used a single license, right? We've transferred the license and all the software from CPU number 1 to CPU number 2. So you don't need a pre-provisioned guest license on that second CPU. And all of the networking has followed that converged infrastructure because it's converged. There's a single wire that now assumes the logical profile of the original wire. So,
Ken, just to confirm that what we're saying here is that we don't need two sets of the hardware, and where before you would need two sets that are absolutely identical to do some form of V-motion or moving. And also that we can do this for whatever the operating system workload is, whether it be a hypervisor sitting on the CPU or Windows Server 2003 sitting on a CPU.
Right. But this doesn't require, for example, as any form of HA software, any form of clustering. Right. Because
so this is done natively out of the box by Pan Manager.
Right. It's done at the box level and not the software level. Correct. So let's kind of zoom in. Let's pick this diagram apart a little bit and find out. So it's like, okay, Ken, this is kind of cool. Why is it so easy? Is it going to save me some money? What less or what fewer things do I need to buy here? So let's kind of pick this apart and take another kind of closer look here. So traditionally, we might have, this is a very stylized diagram. I'm sorry to take credit for drawing it, but it illustrates the point. Traditionally, we might have 4 blades running, each one being a virtual host. We might have a redundant configuration whereby we might have 4 NICs, 2 HBAs, and KVM ports for each blade, right? Basically adds it to lots and lots of cables and lots of cards. It's all physically configured, right? Cards plugged in with screwdrivers. And they all, of course, have their fixed names and addresses and whatnot. So just lots of things to manage, lots of ports being used. In a converged infrastructure, however, some call this unified computing, by the way, but in a converged infrastructure scenario, this looks a little different. Same blades, but this time each blade only has essentially uses 2 teamed NICs, right? And frequently these NICs, these network interface cards, are actually soldered on the motherboard. We call them LAN on motherboard. So essentially the 2 free Ethernet ports that are on the motherboard of the blade or the server are all we need. And those 2 NICs are abstracted or virtualized with special software drivers that Peter spoke about. So those NICs can present themselves as any combination of logical NICs and HBAs and consoles to the OS. We've reduced the number of wires, right, from heaven knows how many, down to 8. Yet the OS on those blades sees any number of logical I/O devices and logical cables and logical ports. But what we've done is we've gone to a wire-once environment whereby you never recable the systems. You never physically change the I/O ports. It's all done in software. Right. So now what we've done is it's obvious, is literally the physical assets you need to buy are fewer, and the physical maintenance you need is essentially eliminated. So kind of pictorially, what does this look like? Traditionally, we started with a bunch of NICs, a couple of HBAs, a bunch of cables, etc. And we've gone to a situation where every card, every server, every blade just has 2 Ethernet LANs LAN on motherboard, or just 2 cheap NICs, depending on the hardware, 2 cables. That's it. And these are teamed together to provide aggregated throughput, and yet they will present themselves to the OS as any form of logical I/O, naming, addressing, connectivity, et cetera you want. So, gee whiz, this is a way where you essentially never have to buy another fiber channel host bus adapter or converged network card again. It's a very elegant approach.
And just one question, and I'm sure people might have this on their minds as well, is when you remove all these components, what's the effect on the bandwidth?
Yep.
What are the resultant connections out? We might want to touch on that. In the previous slide and this slide, it looks like there's not very many connections for an awful lot of servers. So we might want to spend a few minutes on just kind of talking about how the connections work.
Yeah. Well, let's do that. And actually, you've probably been closer to this than I, but essentially what you're doing is carving up the aggregated bandwidth of these two ports any way that you see feasible. And obviously, the physical ports that are coming off of blades are pushing 10 gig each. It's obviously going to depend on what the vendors provide on the card. But what's been your experience setting these up?
Yes. So yeah, what we're talking about is the LAN on the motherboard. Depending on the blade vendor, there's multiple NICs of 10 gig. And then when you converge the I/O, the PAN controllers actually have multiple 10 gig E connections out to the rest of the world in terms of connecting to your core switches in your data center. And then obviously for your storage, we also have in the controllers 4 8 gig fiber channel cards as well. So if you look at the utilization, you're never really ever going to saturate that amount all at one time.
Great. So let me. I'm going to pause for a minute. I saw a couple of questions come in through the chat area. One question has to do with is this similar to another vendor's I/O virtualization approach? They all differ a little bit. As I said, this Egenera's approach is fully software based, where the I/O virtualization is done at the software at a device driver level. There are other approaches that use either full hardware I/O virtualization, as with the CNA card, and then there are other approaches that kind of use a hardware software appliance approach. So lots of different ways to do this. And then there's one other question. Perhaps other people are having this problem that someone's saying that their video is not rendering properly. If that's the case with you, you should both be able to either download a copy of the presentation from your user interface, or worst case, I'll make this available through email. If you email us at info at egenera.com, I'll make sure you get a clean copy of this. And I apologize if the rendering's not working properly for some of you. So let's go from this per host diagram, where the physical complexity and the physical cost is obviously reduced. Now, kind of to a larger situation where we might be dealing with a disaster recovery situation with VM clusters, where we might have a bunch of multiple production environments, a bunch of hosts, licenses, I/O, etc., for a series of 3 production environments. In the case of disaster recovery, what we can do is take any one of those 3 production environments with whatever its configuration was of names and networking and I/O and whatnot, and transfer that production configuration to a shared recovery environment. All right, so you now have 15 servers, but they're bare metal. They're not pre-provisioned with anything. There's no licenses on them even. No host licenses, whatever. And even the I/O and the networking on this recovery environment is what I'll call cold. In other words, it's unconfigured. So rather than needing a complete homogeneous environment across all production environments and the recovery environment, you can have, if you desire, heterogeneous environments in your production and essentially an unconfigured recovery environment that can take on the full personality, the host names, addresses, networking, storage naming, etc., of any one of those production environments should they fail. So this is another alternative to doing disaster recovery relative to, for example, what some of the virtualization vendors do, depending on your need. So I'm just going to summarize here. We're actually wrapping things up relatively quickly. So we're going from this concept of where the market is assuming a fixed I/O configuration to one where the I/O, the infrastructure, is now virtual as well as the software being virtual. And kind of the outcome here is virtualizing your infrastructure is having a logical rather than physical set of NICs and HBAs, portable addresses, et cetera, as I said, which both reduces the hardware you need to buy, and gives you essentially infinite flexibility for how you want to configure that infrastructure, right? So the concept of vMotioning, if you will, your infrastructure. Little bastardization of the term there, but hopefully it illustrates what we're talking about. What I'm going to do here, just for a couple of slides, is talk about how this is implemented, and then open this up for questions. When we talk about our software, and we're certainly not the only people doing this, but we like to think it's the most elegant approach. You start with standard x86 servers or blades. The Genera product, the Genera product is called Pan Manager, and that's that software layer that essentially resides as a set of drivers for your I/O, as well as actually a control system that sits. That's an out-of-band control system. And on those blade servers, you might be running whatever workloads you want. Today, we've mostly been talking about the workloads on the left, virtual workloads, whatever they are. But you could just as easily run physical workloads on your blades as well. The blades really don't know and don't care. And then what Pan Manager does is it pools, obviously, your I/O and your switching and your networking, and configures that logically. It pools and reconfigures your hardware. So we're operating on a number of different hardware platforms. More to come soon, actually. And it's compatible essentially with any SAN, fiber channel SANs that are out there as well, right? So essentially, it's that conceptual layer within the server that helps you abstract or virtualize your infrastructure. Quick product. Yes, Peter.
Sorry, no, I was just going to add to, obviously we've seen here the Genera Pan Manager and the licensing model is that we have a modular approach to licensing in that you kind of only pay for the features that you require. So by default you would buy a thing called Pan Builder, and then we have two add-ins, if you like, for delivering the high availability, and then an add-in for the DR. Functionality, so PAN portability and server PAN portability.
Right.
And then you basically choose how many servers you want to protect with HA. So in a blade chassis, typically you have 16 or 18 blades, depending on the vendor, and you might choose only to protect 5 of those with high availability, in which case you buy 5 licenses to protect.
And this is all licensed, I assume. What you're referring to is licensed by the blade, not by the socket or by the core.
Correct. It's per blade.
Right.
Very simple model. So it's no confusing about number of cores and number of sockets. It's a blade server.
Great. Okay, so there's a couple of questions coming in, so I'm going to get to those in a minute. Real quick, from a product perspective, I want to reiterate something here. We're talking about standard blades that you can buy off the shelf that's compatible with this sort of a solution. Standard Ethernet. The approach that we've taken is to use standard Ethernet switches and cabling, as opposed to fiber channel over Ethernet, as opposed to InfiniBand, as opposed to some other things that are out there. This will work with essentially any major fiber channel SAN array. It's all been qualified with those. Work with essentially any VM or physical OS. So all the major VM players, all the major OS players, Linux OSs. And it's just essentially a single console where you provide provision server templates that you instantiate, IOs and infrastructure templates you instantiate on different blades or servers. It gives you configuration and the HA and DR functionality. So wrapping things up on essentially the last slide here, here's the answer to the trick question. This product we're talking about here has essentially been used in production for 10 years. This kind of I/O virtualization and infrastructure virtualization was actually first used late in 2000, early 2001. So it's actually not as newfangled as you would think, for those of you who thought the answer to the trick question was 1 or 2 or 3 years. Used pretty globally, customers in every vertical, qualified essentially with every piece of major OS and host virtualization out there. So with that, I want to open this up for questions, and I see a couple have come in. So let me get to those first, and then and Peter, maybe you can help me with some of these.
Yeah, sure.
First question I see here is it asks, is it necessary or not necessary for the converged infrastructure to be replicated for backup environment? So I think the gist of the question was, what do you need in the backup environment and what don't you? And maybe I'll answer it this way, and keep me honest here, Peter.
Yeah.
You need the eGenera controller and software available in the backup environment, and you need SAN replication at the backup environment, but that's all. And essentially, through the magic and wizardry of our software, if a production environment fails, the definition files for the production environment, the files that say this is what your I/O looked like, this is what your network looked like, this is what your addressing looked like, this is what your boot sequence looked like, is all transferred over to the controller on the recovery environment, and then that recovery environment is reconstituted, and essentially the software and its licenses are rebooted on that new recovery environment. So hopefully I answered the question. Peter, anything to add? Was I accurate there?
No, you were spot on. So all I was going to add to that piece was the hardware, as in the blade servers themselves on the backup side, do not have to be the same as the ones on your production side. So you could, depending on whether or not your applications will be upset by it, you could go for less CPU and less memory in that approach. So you don't have to buy like for like.
How about, by the way, how about if I have Intel in my production and AMD in my recovery?
Yeah, no, we can do that as well. Unlike some of the hypervisor failovers, we can actually go from one. They stipulate you almost even have to have the same, absolutely identical stepping level on a processor. Whereas Pan Manager says that's fine. I'll go from Intel to AMD. That's not a problem. It's sort of the hardware and the I/O is virtualized. It just sees CPU resource, so we can actually go from Intel to AMD if that was what you wanted to do.
Good. Next question came in, is 64-bit architecture supported with this?
In terms of the operating systems, absolutely. The blade servers we use are standard Dell PowerEdge M610, 710, and in Fujitsu, the BX900 series. They've all got 64-bit processors, and we support 64-bit OS, no problem.
Okay, great. Okay, next question. What if I don't have blades but normal 4U servers?
Okay, do you want to answer that one in the marketing way, Ken?
Yeah, actually, I think the answer is no at the moment. I think at the moment we're supporting blade architectures only. But there's no technical reason why we can't do this with regular rack servers.
Yeah, no, I mean, from a technical server architecture piece, yeah, absolutely, we can do it. The reason for doing it with blades is because everything is nicely consolidated from the hardware perspective before we even start consolidating. So it's just a neater solution with integrated switches. We only need 3 switches in the back of a chassis. We don't need the 5-channel switches. So if you were to kind of implement that, and we do actually have it, one of our first Dell PAN systems was based on PowerEdge 2950s, 2U servers with multiple NICs. And it just looks a bit kind of like spaghetti junction at the back. So by doing it with blades, it's much easier. And when you're talking about this number of servers, it's also less rack space. Less real estate in your data center and less power and all those other good green things that go along with it.
Excellent. Okay. A couple more questions. So another question here. Could we explain how this solution is positioned relative to infrastructure as a service? Care to take that?
Thank you. Yeah, I mean, basically, we see the PAN Manager solution as as ideal for kind of cloud-based and infrastructure as a service, because we've got this flexible approach. In that once you've provisioned a server and built an image, you can store that to one side and call upon it at any time to re-provision a server, and then change it from Windows to a Linux base or even back to a hypervisor, whichever you want. So in terms of that, it's very easy to provision a server. It's just kind of about 6 mouse clicks because it's this wire once environment with images already pre-built. I mean, we have, I think, Ken, correct me if I'm wrong, some papers on that on the agenera.com website on building the basis of a cloud infrastructure and infrastructure as a service. So there's an infinite more detail available there if you want to go and have a look there.
Right.
Or we're happy to have conversations offline and go through some more information if that be needed.
Great. Okay. I see just one other question that came to me. And I think we may have highlighted this, but so what degree of overhead does this sort of a system add to the I/O?
It doesn't. I'm assuming that's like when you add a hypervisor, obviously that needs 5% of the utilization of the hardware upon which it's running. We're just using drivers. There is no overhead other than what a normal driver would take. So if you were to build, say for example, an ESX server, you would build that via the PAN GUI because the blades are participating as part of a PAN managed solution. And as you build that via our GUI, it actually puts the agenera drivers in there. The agenera drivers are all signed. We're part of, in this case, the VMware Alliance program. Our drivers are tried and tested, so they basically go into the hypervisor. If you're in a Citrix world, our drivers would sit in the domain 0 in the control domain. Windows, if you went and looked in the device manager, similar to when you virtualize Windows on top of a hypervisor, you see things like VMXNet, for example. On a native Windows box sitting on PAN Manager, you will see eGenera network drivers. You will see eGenera SCSI drivers. So we're just at the driver level. We're not adding any complication or extra level of resource on top of that.
Okay. All right. So I don't see any more questions coming up, but feel free to ask some or submit them to info@egenera.com. Hopefully this was at least slightly enlightening in terms of alternate approaches to doing disaster recovery and high availability, and hopefully it was a little enlightening in terms of how you could both simplify your I/O and infrastructure and actually reduce its cost at the same time. So with that, by all means, contact either of us, either Peter or I, directly if you have a couple of questions. Sounds like some of you might have had trouble viewing this. By all means, shoot us a quick email, and I'd be happy to send you the slides. And Peter, anything to add?
No, just thank you very much for those that have attended. I was going to say it's fairly late in the day, but it's not for probably those on the call. It's just me who's late in the day. So.
Very good. All right then. Well, thank you everybody.
Thank you very much.
And again, please feel free to inquire.